Hello. Okay. Hello, I'm Jian. I'm representing AI Singapore, and I'm very happy to be here to share a little bit about Sea Lion and some of the other ongoing efforts that we have. So, without further ado, I'll start. So, today's theme is really about the challenge of trying to build a truly representative LLM for the Southeast Asian region. So, we all know that large language models have transformed how we interact with AI, right? Since ChatGPT, especially. Um, but their effectiveness depends entirely on the data that they are trained on, right? So the majority of existing LLMs are built predominantly on English and Western-centric data sets, and this has led to a significant representation gap for other regions, such as Southeast Asia. For the diverse linguistic landscape of Southeast Asia, there are over 1,300 languages across 11 countries. This is a significant challenge, right? There's a lot of diversity that needs to be captured. So this representation gap in LLM training means that a generic LLM, one that might be very well trained perhaps, often fails to understand or generate content effectively in the Southeast Asian context. And this will limit AI adoption for hundreds of millions of people. In Southeast Asia alone, there's more than 680 million people, right? So all these people are going to be affected by the in unequal access, I should say, yeah. As mentioned, there's a lot of linguistic diversity, right? And even though there are so many languages in the Southeast Asian region that are spoken by millions of people, there is a very, very limited digital footprint for the C region. And a lot of the languages are very low resource for your standard LLM training approaches. So this is a problem that has many parts to it, right? Creating representative LLMs for the C region goes beyond simple data collection. We need to find the right data and we need to process it effectively. So there are quite a few technical obstacles, right? And here there are a few that I will talk about. So the first one is scarcity and complexity of the C data, right? There is limited high quality machine readable text for many of the regional languages, and this creates a fundamental data shortage. Also, many C languages have unique scripts. There's also a lot of code switching, right? Sometimes between different scripts, or maybe like it's a Latin script and maybe like Filipino and English, for example. You can do code switching, but at first glance, it looks like it's the same because it's the same script, but it's not, right? And there are a lot of challenges regarding standard data processing pipelines. There's also ineffective filtering of data, whereby standard data filtering techniques will often end up discarding valuable non-English content or fail to identify culturally relevant material, maybe because some of the language that is informal might also tend to be like with non-standardized spellings, and that might get discarded because it could be incorrectly filtered as low quality data, for instance, right? So we also need to increase model accessibility for non-English users. And we need to fine-tune models to output more culturally appropriate responses for better and safer human model interactions. This will lead to higher AI adoption, right? Again, the Southeast Asian region is huge, but the AI adoption is very limited by the fact that a lot of models are English or Western-centric. And one last problem I'll bring up here is the lack of regional benchmarks, right? You need a standardized evaluation metric for at least talking about the C languages, right? You need a standardized evaluation metric. Otherwise, it's very difficult to measure progress, yeah? So I'll share a little bit on the technical side. This is regarding pre-training data, right? So after we investigated why existing data collection methods were failing for the C region, we had to engineer a new data paradigm through the Sea Lion data pipeline. And we tackled quite a few technical challenges with some hopefully innovative solutions. So the pipeline implements targeted strategies for data acquisition, custom filtering techniques tailored to Southeast Asian languages, and specialized tokenizations optimized for the morphological richness of regional scripts, right? We've also explored responsible data augmentation for some of the data sets. So just to quickly highlight, so for example, there's the quality filtering, right? And then there's the tokenization, perplexity bucketing, because you have different languages that we're working with and different scripts, right? There's also, okay, so we talked about the pre-training data. This is a bit on the post-training data. This is a snapshot that's based on a much earlier model, the Sea Lion V3, back in October 2024. So to talk about some of the instruction fine-tuning data that we used, there's a mix of Infinity Instruct, Open Math Instruct, and our own C Instruct. which we built using synthetic data generated with MagPie, and also includes handcrafted data in some of the Southeast Asian languages, right? At the time, it was a little bit more than 20 million instructions across the languages. Okay, so there are also non-technical solutions, because technical solutions alone can't always bridge the vast data gap, especially in our region where a lot of the data just does not exist, or does not exist on the internet at least, right? So we have to build like collaborative initiatives to engage communities across the Southeast Asian region in our data collection efforts. So I'll just list a few here, right? There's Project SEAL, which is a landmark initiative with partners like Google and some of our other Southeast Asian partners, to systematically collect, digitize, and open source culturally significant data. There's also the Aquarium platform, which is something that we're currently developing. There is a V1 out on the internet already. It's a centralized hub facilitating data sharing, hosting, curation, and discovery among stakeholders. So you could use this, for example, to do your gap analysis for data that is lacking for a particular language in Southeast Asia, for example. There's also a Pan Southeast Asian network, right, where we partner with universities, research labs, and cultural institutions across all of the 11 countries in Southeast Asia. So hopefully, we're able to build a foundation for inclusive and effective AI, right? So there are a few parts to this. One is CPAL, which is our data cornerstone. It's a massive data set, over 1.5 trillion tokens, right? Hopefully, it provides a robust foundation to train Southeast Asian language models through an advanced data pipeline and collaboration. And then we also have our regional benchmark, CHELM, which is a holistic and culturally relevant evaluation framework to fairly measure model performance across diverse Southeast Asian languages and tasks. So essentially, this is to measure whether your models are actually able to support capabilities in Southeast Asian languages, right? And then we, of course, have the Sea Lion flagship models, right? They're open source from V1 to V3.5 is our latest release. And they deliver top performance for Southeast Asian languages. They've been trained on CPAL, and evaluated with CHELM. And something more experimental is CGuard, right? So it's to do with safety. It's an upcoming AI safety system designed on rich data, and we hope that it can create an effective and culturally aware safeguard for AI models. Here's a snapshot of what our leaderboard looks like. This is publicly available. So CHELM is built in close collaboration with native speakers of Southeast Asian languages. It is a holistic evaluation for Southeast Asian capabilities. Currently, we cover Indonesian, Filipino, Thai, Tamil, and Vietnamese. And we have more expansions planned very soon. So there's a variety of tasks included, such as instruction following, multi-turn chat, linguistic diagnostics, sentiment analysis. There's a lot more that you can read from this slide. Maybe it's a bit small. I'd like to bring our attention also to some of the ways that we break down the reporting of the results. So we have models that are less than 10 billion, and then we also have models that are more than 10 billion parameters in size. But we also look at instruction tuned models versus like base models, right? And you can see that there's a breakdown by task, by language. You can go to a detailed view and so on. Okay, so I think I made good time. So I've come to the end of my presentation. If you want to find out more, you can use the QR code, or you can go to sea-lion.ai. That's sealion.ai, right? You can access our playground, you can access Aquarium, you can access the CHELM leaderboard, quite a few other things to explore. Yeah, thank you. Any questions? Yes. Yes. I can't remember the exact details, but it is based on Common Crawl, except that we don't just take it as is. So we've done a lot of processing, right? If I go back to, yeah, so we've done a lot of processing of the data, right? I can't remember which snapshots we used. It might be like the latest 20 snapshots or something, because we can't use the entirety of it, right? We don't know how much of that data has already been seen by some of the models that we're working off of, but I mean, I guess nobody knows, right? Unless you really build everything yourself. Yeah.
So just to follow up, because within the Swiss LLM that we're developing, we also have a sort of low resource language that we care a lot about, which is Romansh. We have access to native speakers there, which is why we can actually work a little bit on figuring out how to improve it. But it is actually quite difficult once once you have exhausted the data that is on the web, have you already thought about what are good strategies on improving the downstream performance on these low resource languages that might not just require going out and collecting data or license data or whatever?
Completely agree. Yeah. I don't know if it's good. I'm not confident enough to say that it is. There's a few ways we think that we can tackle this, right? One is with trying to synthetically generate data from what's already available. You can do this on both the pre and post training side. So, you can do this at like the mid training stage, right? Basically, where you introduce hopefully more high quality data. But then you have a chicken and egg problem. If your model only has seen so little of a particular language, like say Romansh, like you cannot guarantee that the synthetically generated data is any good. So you may need to, for example, involve humans in trying to validate whether it makes sense, right? Like, is it coherent? Is it actually like free of spelling mistakes, grammatically correct, and all that kind of stuff, right? If you really want to call it high quality data, that's potentially one way you can do it. Another way would be to synthetically generate data on the post-training side, right? Which is this part. So here it can be, I suppose, a bit more targeted because in pre-training, you use a lot of data that's unstructured, for example, or it can be structured, but it has to be structured in a very different way than with SFT data, right? So with SFT data, you can be a lot more targeted in terms of like the domains or the tasks that you want the model to be able to perform in. And in that sense, maybe it's actually potentially easier to see a bit of gain. I'm not saying that SFT will be able to impart new information. That's not how it works. But assuming that the model has seen some data of a particular language, even if it's very little, it's possible that with high quality SFT data, you can actually draw something out of a model, right? It can be iterative. Maybe it's not so good at first try, and then but you find, hey, it's not bad, and then you can slowly iterate, do more and more synthetic generation that's like more refined, and then ultimately you might be able to get to a stage where you actually can have better pre and post training data for it.
Okay.
No more time for questions, or
No.
sorry.